Okay, here we go. I've got something prepared from the Desmos online graphing calculator. I typed in the original function, f of x equals this mess. I use the Desmos derivative operator to define g of x as the derivative of f of x. And then I actually use logarithmic differentiation to get q of x. And h of x is the result of actually multiplying f of x times each term inside this parentheses. And you can see it's quite messy. But you also see that down here in this table that Desmos doesn't like q of -2. And that's because it probably calculates the value of this term here that has x plus 2 in the denominator. But after you multiply through by f of x, none of these denominators become 0 except when x is 0. So anyway, the idea is to take the natural log of both sides. In here is the original log of f of x. And then we use the properties of logarithms to explode this logarithm into separate logarithms using properties of logarithms. The log of a product is the sum of the logs. The log of a quotient is the difference of the logs. And we also have that property, like if you have the log of x to the 5th, that's the same as 5 log x. So that's how I got these exponents down front, 2, the 5, and the -1/2. Now we're ready to take derivatives using the chain rule, and the derivative of the log of y is 1 over y times y prime. Had to use the chain rule, so y is a function of x. 2 times the derivative of the natural log of x plus 2 is 1 over x plus 2. And we have to consider using the chain rule at that point, but the log of x plus, or the derivative of x plus 2 is just 1. For here, the second term, we have 5 over the derivative of the natural log. Ln of x squared plus 3 is 1 over x squared plus 3 times the derivative of the inside, chain rule, which gives us 2x up here, minus the derivative of ln of x is 1 over x minus 1/2 times the derivative of the log. Ln of x squared plus 4 is 1 over x squared plus 4 times the derivative of the inside, which is 2x. Okay, and all of that simplified here. And whereas these 2's cancel out. I think that's actually the only thing that changes. And this 5 times 2x becomes a 10x. Okay, and now how do you solve for y prime? You multiply both sides by y. So in brackets, I've got this mess multiplied by y, or by f of x, as I've done here on Desmos. And again, if you distribute f of x times each term in here, you get this really ugly looking mess right there. But Desmos, by setting up this table, seems to confirm that these are correct answers. So there you go. Hope you understood what's involved in logarithmic differentiation there.